Unit 4, Lesson 9, here we go, multi-step equations. So, we say as math teachers, you're going to need this later, you're going to need this later. So, equations that you might have been able to solve in your head previously are now getting to a point where there's enough steps that you need to be able to show the algebra, and you need to have all of those little steps that we've been mentioning since Unit 3 of MSM2. So students will be able to solve equations where there are variables on both sides of the equal sign. Here we go. Yesterday, you learned about two people who were each trying to save $1,000. Sarah had 200 and saves another 30 each month. Janet is starting with 140 and saves an additional 50 each month. You used a graph to find where the two girls will have saved equal amounts of money. How was this shown on the graph? So on the graph, that was the point of intersection. That was where, after 3 months, they both had $290. It was the point where they intersected. How could you use tables to determine when both girls had the same amount of money? So if they had the same amount of money in the same number of months. So we were looking for a dollar amount that was the same after the same number of months. Not difficult, but a little less obvious than the graph. You can also use an equation to find out when the girls will have the same amount of money. So what we're looking for is, when will Sarah's savings be equal to Janet's savings? And that's all we're doing, is just setting them equal to each other. Sarah's savings are being set equal to Janet's savings. When will they have the same amount of money? The equation above has variables on both sides. What would be your first step in solving an equation like this? First thing you're going to want to do is to focus on getting all the variables to one side. And it doesn't really matter which side. Whatever is going to be slightly more convenient is usually what I go with. So I can either move the 30x to the right, or I can move the 50x to the left. Now, I've done this for a while. I'm going to take the smaller one and move it to the right. I can subtract the whole term from both sides. Now, the reason I did that was because I knew positive 30x minus 30x was going to cancel. And over here, I was going to have 50x take away 30x, which still leaves me with positive numbers. And that's usually my goal, to work with positive numbers as much as possible. So what I did there was I subtracted the whole term from both sides in order to cancel the variables on the left, move them all to the right. Now I have a standard two-step equation. I'm going to subtract 140 from both sides. I'm going to divide both sides by 20, and I'm going to get 3 equals x, or I can say x equals 3. They have equal amounts after 3 months. And I know that because I set them equal to each other. Now, what's funny is I don't know how much they have. I just know that they have the same amount after 3 months. If you also wanted to know how much they have, you could pick either of them and say, what is 140 plus 50 times 3? Or what is 200 plus 30 times 3? And that would give you the amount that they both have. So let's put this into practice. If we have equations where there are variables on both sides, first thing I want to do is get them all to one side. So I can take away 3x from both sides, or I can take away 1x from both sides. Taking away 1x is going to leave me with 3x take away x, a positive. 18 plus 2x equals 24. I subtracted the whole term, which in this case was just 1x. Subtract 18 from both sides, since I have a standard two-step equation. Divide both sides by 2, and I'm going to get x equals 3. Not terrible, but that does add one more step than our traditional two-step equation from before. Here, 4x minus 3x. Now, this is great because the opposite of subtracting 3x is adding 3x, which I know is going to result in positive x's on the left. So 4x plus 3x is 7x. Minus 7 equals 2. I'm going to add 7 to both sides with my regular two-step equation here. Now, some people will think they've done something wrong when they get to this point, and they're like, no, 9 doesn't equally divide by 7. Nope, it doesn't. But you can leave your answer as 9/7, and there's nothing wrong with that. Improper fraction in lowest terms. Last on this side, I've got minus 5x and a minus 7x, or they're both negatives. So I've got to think about A, it doesn't actually matter. It's going to work regardless of which one you add to which side. But I'm going to add the 7x. Since it was negative, I have to add a positive 7x and add a positive 7x, which is going to make the negative 5 with the positive 7 a positive 2x. Again, you can do it either way, still going to work. I'm going to add 8 to both sides. Since the variable side had a minus 8, I'm going to add 8. 1 plus 8 is 9. And again, I get people all the time, they're like, oh, I did something wrong. No, you didn't. Fractions, improper fractions, they work. They're fine. They are perfectly acceptable numbers. Now, if you wanted, you could use 4.5 or 4.5 as a mixed number. That would be a correct answer as well. Now we've got some things here that are going to apply the algebra to a geometry context. Each figure below has equal perimeters. Now that is super important for this question, that we recognize that they have equal perimeters. We're going to need that fact in a moment. So I'm going to highlight that, equal perimeters. Write a simplified expression for finding the perimeter of the square. All right, so perimeter of a square is 4 times the length of one side. So the perimeter of this square is going to be 4 times x minus 3. I would use the distributive property. 4 times x is 4x. 4 times 3 would be minus 12. I'm also going to find the perimeter of the triangle. Now you'll notice that the triangle, it is not equilateral, so I can't just multiply it by 3. So nothing fancy here, x plus 8. And then I would simplify. I can add the 2 x's to get 2x plus 8. Now, it does say write a simplified expression. So the actual answer here is 4x minus 12. That is an expression. The actual answer to this question is 2x plus 8. That is an expression. You might also see that you could do 4x minus 12, put it in parentheses, and write units, since inches and feet and meters were not given. The second one, you might see 2x plus 8 in parentheses with units for the same reason. Find the value of x. Remember that the perimeters are equal. So I can set those two expressions equal to each other, because the perimeter of this one is equal to the perimeter of this one. If I want to do that, first thing I'm going to do is take away the entire term, the 2x from both sides. I did that because 4x minus 2x is still positive. I have a two-step equation. I'm going to add 12 to both sides. 2x equals 20. Divide both sides by 2, x equals 10. Now, it said find the value of x. At this point, sorry, I went off the screen a little bit. At this point, I am technically done. The question asked us to find the value of x. If, however, and I've seen this a lot on standardized assessments, you were asked not just to find the value of x, but to find the perimeters or to find the side lengths, what you would need to do is take that x equals 10 and go back and say, okay, well, if x equals 10, 10 minus 3 is 7. All of the sides of the square would be 7. Or if x is 10, 10 plus 10 plus 8, you might need to go back and actually substitute into the original diagram. Another thing you might be asked to do is 4 times 10 minus 12, or 40 minus 12, and you would say the perimeter is 28 units for the square. If you did the same, 2 times 10 plus 8, 20 plus 8, 28 units is the perimeter for the triangle, which makes sense because the whole setup of this was that they had equal perimeters. So they should, if you substitute the value of x in, come out to the same perimeter.